Hello class, this is Mrs. Lyons. We are going to take a look at what a reaction would look like if we were looking at it, if we could see the atoms and molecules and how they react with each other. And the purpose of doing this is to look at how reactions happen in the real world. And what I mean by that is when two things react, they react until one or the other or both of the reactants runs out. So we want to look at that. What does that look like visually? And then can we connect that visual image and visual analogy with the mathematics that we'll be doing? Okay, so we're going to use this example. We have the reaction of lithium and the reaction of nitrogen gas to produce lithium nitride, excuse me. So, and what we're going to look at, we're not going to look at the balanced equation yet, okay? What we're going to look at instead is we're going to draw pictures, okay? And what we're going to draw a picture of is we're going to draw a picture using the example of having 10 moles of lithium and 5 moles of nitrogen. And then we want to see from that how many moles of lithium nitride would be formed. Okay, so what I'm going to do is I'm going to make a little key over here. What I'm going to say is I'm going to make lithium represented by a triangle, and I'm going to make nitrogen represented by a circle. Okay, so I'm going to draw, this says I have 10 moles of lithium, so I'm going to say that each triangle is 1 mole of lithium. And remember, we know that 1 mole is that certain number. So if I have a mole of one thing and a mole of another thing, I have the exact same number of both of them. So if I have a mole of lithium and a mole of N2, I have the same number of lithium atoms as I do N2 molecules. So I'm drawing 10 lithium. So 4, 5, 6, 7, 8, 9. Did I do that? 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 lithium. And then I want 5 moles of N2. So the thing that I have to remember is since nitrogen is N2, it's one of those 7 diatomic elements that make up Haber-Finkel, I would draw each mole of this would be 2 circles that are connected, indicating that they are bonded together. Okay, so I've got a picture of 10 lithium and 5 N2s. Okay, so what we're going to make from this is we're going to make lithium nitrides, and each lithium nitride has 3 lithiums and 1 nitrogen. So to show how to do this, I'm going to take 1, 2, 3 lithium and 1 nitrogen atom, and I'm going to put those together. So I'm going to do it like this. So what you'll see what I'm doing is I'm connecting. Okay, so I have 1 nitrogen and then 3 triangles are the lithium. All right, so I'm going to keep doing this until I run out of things to put together. So if I'm going to make another lithium nitride, I would do 1, 2, 3 lithium and another nitrogen. So it would look like this. I still have stuff left, so I'm going to do 1, 2, 3 more lithium and 1 more nitrogen. Okay, and now I can't make any more molecule. I can't make any more lithium nitrides, Li3Ns, because if you look, I don't have enough of one of the reactants. And the reactant that I don't have enough of is lithium. Okay, so what that means is I run out of lithium. So we have a name for that when we're talking about stoichiometry and we're talking about these equations. the reactant, the chemical compound or element that runs out first is called the limiting reactant. And it's called the limiting reactant because it limits the reaction. Okay, it's the reactant that runs out first. If we had more, the reaction would keep going. Okay, so what we can see in this picture is that if we had 10 moles of lithium and 5 moles of nitrogen, we could make 3 moles of lithium nitride. All right, and we would have excess nitrogen. Okay, so that would be the excess reactant. All right, so what I want to do is I want to kind of think about this in terms of the truth tables that we've been doing and in terms of the math that we've been doing. Okay, so keep this picture in mind. And we're going to jump over here and we're going to think about this in terms of a question that you might have been asked on a worksheet in the last couple of days. All right, so I might ask you, how many moles of lithium nitride would be produced if 10 moles of lithium reacted? So what I'm saying is, if I start with 10 moles of lithium, mathematically, what is my mole map and my dimensional analysis going to tell me? How much lithium nitride can I make? Okay, so now we didn't balance the equation before, but we're going to balance it now. Okay, so if we look, I've got 2 nitrogen here and I only have 1 here, so I'm going to put a coefficient of 2 here, which gives me 2 nitrogen on each side. Now I need 6 lithium, so I'm going to put a 6 there. So my coefficients are going to be 6, 1, 2. All right, so if I look at this question, this is saying how many moles of lithium nitride, so remember in our mole map, lithium nitride would be our B, okay, would be produced if 10 moles of lithium reacted. Okay, so lithium is going to be our A. All right, so I'm going to set this up. We always start with our given, so I have 10 moles of lithium, okay. We're only going to have one step in our truth table because we are going from moles of A to moles of B, okay. So we know that our units come down here, moles of lithium come down diagonally, and since we're going from moles of A to moles of B up here, we're going to have moles of B, which is lithium nitride. Okay, so when we have moles over moles, all right, so we've got moles of one thing compared to moles of another thing, we know that we are going to use the mole ratio to figure out what numbers go into our truth table. So if we look up here at our balanced chemical equation, it tells us the coefficient in front of Li3N is 2, and the coefficient in front of lithium is 6. So I'm going to plug into my calculator 10 times 2 divided by 6, and that gives me 3.33 carried out. Now, this is a kind of a bad example because we only have one sig fig. So at this point, I'm just going to leave this number here because I want to see how it relates back to the picture that we drew. So I'm just going to leave 3.33 moles of Li3N. All right, sorry about that. Raider saw something going on outside that he thought he needed to bark at. Hopefully he can be quiet now. All right, so by doing this math, we've determined that I would have 3.33 moles of lithium nitride if I started with 10 moles of lithium. So we're going to do a second mathematical calculation. All right, and the second thing that we're going to look at is how many moles of lithium nitride would be produced from 5 moles of N2. So if you remember our picture that we drew, Raider, stop. Okay, we're back. Let's try to finish this up. So I started, the example that we drew, I started with 10 moles of lithium, 5 moles of nitrogen. So we're going to go over here and we're going to calculate mathematically, if I start with 5 moles of nitrogen, how much lithium nitride could I make? Okay. Shh. So I have 5 moles. Okay. We start with 5 moles of N2. And we're going to try to figure out how many moles of lithium nitride I could make. Okay, so we know moles of N2 go here. And again, we're going from moles of A to moles of B. In this case, again, moles of B. B is lithium nitride. Okay, so we're going to get our numbers from our balanced chemical equation. So the number for lithium nitride is 2. The number of moles for nitrogen is 1. All right, so let's see what this, if I plug this into my calculator, oh, I don't really have to plug this into my calculator because this tells me that if I use up all 5 moles of nitrogen, I could make 10 moles of lithium nitride. All right, so what this is saying, okay, conceptually, okay, so let's look back at our picture. We said that we would be able to make 3 moles of lithium nitride. And if you notice, we had 1 mole of lithium left over, which would kind of equate to that 0.33, honestly. Okay, so in doing this, what we're comparing is we're figuring out what would run out first. Okay, so if we had 10 moles of lithium, our reaction would stop after 3.33 moles was made. So let's write this down. So 3.33 moles, all right, after 3.33 moles of lithium nitride were made, the reaction would stop. Okay, now go back to the nitrogen. Okay, so if we were to use up all 5 moles of nitrogen, that would give us 10 moles of lithium nitride. Okay, so in all of these examples from now on, when we're looking at limiting reactant or what runs out first, we're always going to compare the 2 reactants. So we started with lithium, we started with nitrogen. All right, the mathematical equation that has the smallest answer, okay, that gives us the smallest amount of product, is going to tell us what our limiting reactant is. And the limiting reactant is always going to be, as the name says, a reactant. So we're always going to have to look at what did we start with. So in the equation, the mathematical equation, when we got 3.33 moles of Li3N, we started with lithium. So that tells us that lithium is our limiting reactant. Okay, so we can prove that mathematically, and we can prove it visually, because when we did this example, lithium is the thing that ran out first. So I hope that helps clear up, helps you understand a little bit how we can visualize these types of reactions. That is all for this video. I will see you in class.